Hello, I'm Ettore. I am a student of the school which was previously founded by Elon Musk. I like to build and create stuff and learn. And today I'm interviewing the ASTRA Aerospace Rocket Engineering team from the Bremen University of Germany. What is your team and its story and your mission?
So the team is super new. We just started last year in February. I recognized that there was kind of a problem at the University of Bremen, which is that we have lots and lots of space-related majors and people who want to do space-related engineering, but there was no like team to express that all that knowledge in a physical way. So we were kind of all going to the university and learning all these formulas and stuff, but we didn't have a way to apply our knowledge in a physical way where we build something. There had been previous teams in the past at the University of Bremen, but the funding for those kind of went away after there were some issues that they had. And when we joined, the people that are in the group now joined the university. It was in the middle of the coronavirus situation, so we weren't even seeing each other at all. So this was kind of like an opportunity for us to express our knowledge that we have to building something, but also being able to like see each other and have a group and a community online that we can be doing something interesting. And then, of course, we chose the mission, which would be to build a rocket that goes to space, kind of more as a target that will inspire people to get involved. Because if you have a really cool goal, sometimes that's enough to get people interested and start wondering if they would want to contribute. So
I started off a little bit later, um, but all the same, I was still there with the team since the start, and it's been amazing so far. Just watching it grow from where we started and how much we've learned so far. So, regarding meeting each other, actually, Josiah took my interview when I signed up on the website and said, "Hey, I want to be part of Astra." And I kind of came with a mixed background, but I was super happy to see that different parts of my background still fit into the situation. So that's kind of how we met each other.
I'm Taha Merchant and I am the head of propulsion at ASTRA. I work on developing the propulsion system for a rocket which we want to go to 100 kilometers. So I make sure that our rocket engine has enough impulse for us to reach that height. Yeah, we started the team early in 2021, and I think the most common thing, the reason for us to do this was that we were learning our engineering on paper in the university, but there were not a lot of hands-on projects that we were working on. So we thought, well, why not let's just start something ourselves. We can't wait for some project or some opening to come up. So we started a team and decided to start with Project Karman. In my past, I have worked on projects other than aerospace projects since I was studying mechanical engineering. We had a group of us students who had built an off-road car, and we had competed in a national level competition. After that, I decided to start my own um, air modeling club, and so yeah, just a few of us just sat down and started designing airplanes and building and flying them. Participated in a few things, but that was a really amazing experience. And after that, I worked on my bachelor thesis research, so where we analyzed the fluid dynamics of an aircraft and how we could change it to make an aircraft more efficient. So that was something I did before starting my master's here. Um, yeah, I started my master's here pretty much exactly after my bachelor's. There was not much gap in between, and I think that was interesting.
So, how's your university and studying in Germany? And do you study in English?
We have two master programs, which is Space Sciences and Technologies and Space Engineering. Josiah's from the Space Engineering part, and I'm from the Space Sciences part. The master is definitely in English, and it's yeah, like a regular master program in Germany where you don't have to pay any tuition fees, which is great. And all the fee that we pay is close to 340 at the most per semester and 340 euros. And this is all essentially towards the transportation because tuition is supposed to be free according to German law, but you also have to go around and use the transportation buses to get places. And this is really all we pay for. Other than this, the fee also includes something like a culture semester ticket, where you kind of get to explore some exhibitions as a student at really low prices. Yeah, for the visa, I think maybe we had different procedures because we applied from different places. But for me, from India, it was quite a long process and quite some difficulty getting slots. But essentially, was a student visa that we applied for, which is valid for the first year that you're here, and then you apply for like a residential status. And yeah, that covers about how the visa situation works. And living expenditure, I think that German law asks for foreign students to have something like a blocked account, where you approximately spend maximum like 700, 800 euros per month, which includes your rent, health insurance, tuition fee, any other living expenses. And yeah, so that's few things about being a student in Germany.
I think that pretty much does a pretty good justice to your explanation. The only difference is that if you're already a European resident, it's a lot easier because you don't have to go through the whole visa thing. So I was already a European resident at the time that I applied because I was working in Germany previously. So much easier process. You just send your application and they say yes or no, and you can go.
Our university has its own research institute right here. It's called ZARM, and it is the Center of Applied Space Technology and Microgravity. Other than that, right next to that is the DLR, as Sahana mentioned, where we have the German Aerospace Agency, and right next to that is OHB, which was in fact one of the key founding factors of the space engineering program within the university. OHB was actively involved in starting this the master's program, and yeah, this helped get new space engineers that was required in the city of Bremen, since it was already a space city. Other than that, other players in the aerospace industry within Bremen are Airbus for the aeronautical students, but also Airbus Defense and Space. And along with that, one of the big ones is Ariane Space. That's in Bremen as well. It's near the airport, and Airbus and Ariane share a shared facility. And well, I also work there right now as a student, and yeah, I think that's quite interesting.
So do you have contacts with the other universities or alumni?
Yeah, so from my part, because for 2 years I worked part-time at the German Aerospace Center, the Deutsche Zentrum für Luft- und Raumfahrt. I saw a lot of colleagues who were somewhere in and around Bremen, and also from the University of Bremen. I do have a few friends at Airbus and OHB who previously did their master's or PhD at the University of Bremen as well.
I guess that also has connections with ESA a little bit, because there are some jobs with Ariane Space and stuff that are in the area, so sometimes you can get connected to those types of things.
So I recently got a job as a working student in Ariane Group, and basically I am currently in the propulsion team. So I am currently working on the upper stage of Ariane 6, as well as developing a future engine design for whichever the next Ariane will be, so an upper stage engine. And that, I think, is one of the best opportunities I have received so far. I think that's something that Bremen offers, the exposure to the actual industry. And I think my role in Ariane is quite interesting in the sense that I bring in some experience from what I know already in terms of the work I do at ASTRA, as well as the things I learned in my master's project at the DLR, as well as my experience with Ariane and the industry, things I learned, and how I can apply it for ASTRA. So I think that's quite a unique opportunity, and I think that's something that's available here in Bremen.
What was your preparation before university, like high school?
In Canada, it's not like the whole education system is pretty general, so you kind of all do the same types of things. But you have a little bit of options when it comes to whether you want to focus kind of on like math and science, or if you want to focus on like English and social sciences and stuff like that. And of course, I went down the math and science route because I was always really into rocketry and engineering and building stuff. So I tried to take as many things as I could with respect to science and engineering and physics. I didn't really do anything exciting in terms of engineering in high school, to be completely honest. And this is one thing I wish I did a bit more, because I didn't really know what the options were. I was more of an athlete in my early high school days, so the engineering wasn't as much of a focus.
For me, definitely not athletic as much as Josiah, but I was frequently doing a lot of summer schools and internships at the planetarium, at the Indian Institute of Astrophysics, at the Indian Institute of Science, basically. And I was also working, part-time on multiple projects which were related to space since quite some young age. I used to build a lot of sensors for my telescopes as a kid, to make sure that the lens did not get foggy with rain or something like that. So I think I started small projects somehow related to science and space at a very young age. The cool thing that happened to me during my high school was actually I got to go to the Space Academy program from NASA in Alabama. And this program really kind of gave me a good idea about what's Capcom, what's EVA, what kind of trainings do astronauts have to actually do to get to different places. So I got a taste of everything small at a young age, and I think this was amazing for me. I also did a lot of courses in astronomy and astrophysics. We also had a astronomy of Association of Bangalore for amateur astronomers, and Bangalore Astronomical Society. That's the city where I'm from in Bangalore. So it really helped me that I kept in touch with the astronomy side for quite some time, despite the fact that I did electronics and communication engineering in my bachelor's. And so according to me, if you're in high school and you're looking for STEM education, of course, you start with science. This is basic. But of course, also kind of look for summer school opportunities, space weather schools. Look for whatever opportunities you can get to know as many people in the industry as possible. And yeah, follow your heart and have fun. That's it.
How is it like to be a student in Bremen?
Yeah, I can say before Corona, and unfortunately, Josiah can talk about how it's been after Corona.
Yeah.
I had the lucky chance to be here for a few semesters before Corona, so I have to admit it was a lot more different than how students face it right now. It was definitely fun running from one department to another for lectures, because some of the lectures happen in the institute for us, and also some of the lectures at the German Aerospace Center, because the program integrates a lot of lectures from employees from the Institute of Space Systems at DLR Bremen. So was definitely a fun experience. So to kind of describe like a normal day, it was waking up at 8, no, lectures were at 8 already, so waking up at least like 6:37 a.m. It's still dark outside, and you can start in the winter semester in October, and it's snowing and cold, but you still gather the motivation to turn up to your early morning lecture. And then, as usual, all of us go to the Mensa, which is the canteen or the cafeteria, let's say, for all the students to eat together. And then you attend a few more lectures, and by the time you go home, it's dark again. So it's not as intense as it would be from Space Master students from Kiruna, for example, but I do miss my sunlight that I used to get in India. So this was lecture period during winter semester before Corona. I get Josiah has another opinion.
Yeah, from my perspective, the weather here is great.
Yeah.
It's only snowed like 2 times since I've been here, so that's amazing.
Yeah, this is not Corona, but global warming. But yes, okay. Yeah.
Yeah. On when the coolest thing I think about the university is that a lot of the professors, at least for the space engineering and space science master, are actually working in the space industry, and they're doing real projects, and you have the opportunity to talk to them and to interface with them and to actually do project-related things with them later on in your studies. So it's kind of a really good opportunity to get yourself into the industry if that's what you want to do. I think Sahana and I both are on that track. So
Yeah, for sure. That's definitely been the interesting part for me too, because some of our lecturers, they were involved with EuRoC, the mission from the German Aerospace Center, where they wanted to grow tomatoes in space. And I work very closely to the Eden ISS lab, where they have a huge, like plantation experiment in Antarctica. And there's our NASA ESA astronaut, Jesse, who's also working in the Eden ISS, and they take care of plants under really extreme conditions for, say an interplanetary mission, for example. And to get to just be in the middle of all of these labs where so much is going on, like the next room, someone's testing a smart T-shirt for the astronaut Matthias Maurer to wear it on his trip to the ISS. So being really close to actually current experiments is just really the fun part, because every day you get to hear somebody's experience. Somebody just wants to grab a coffee with you and just tell you their experience for how it was when their satellite was getting launched and what kind of anxiety they had at the launch site. So this human experience of getting to know stories, it's so much easier when you're closer to the industry. OHB, Airbus, DLR, all of them are pretty close to the university, just a couple of streets away, basically, for all the labs. So that's definitely great.
What are your goals and your roadmap towards space?
For ASTRA, the group, we only have one goal, which is to build a rocket that goes to space. So the purpose behind that was, obviously this is a very ambitious target. So we really want to focus ourselves on doing things that will take us to that point. We don't have very many resources right now. We don't have a lot of money. We're having difficulty just getting access into facilities, and we don't have much support from the university at all. So we really need to make sure that, like, every decision that we make and every step that we move forward, we ask ourselves, does this get us to space or not? Does this take us on the path that will take us to space or not? So we've really tried to optimize our plan that we want to take to get there. We'll see if that actually pays out and works, because maybe a lot of people have told us that our plans are quite ambitious and maybe slightly unrealistic. But yeah, we'll see. For our strengths, I think one of our biggest strengths is the diversity that the team has. We have a lot of people from different walks of life that are joining the team, and so because of that, you're able to pick out problems in your design really quickly, because the more you expose it to different ideas and different people, the more chances you have to evaluate how good your designs actually are. I think we also have a strength in that we're all kind of people that are willing to take risks, if that makes sense. We're not really taking the approach right now of, do the safe thing. I don't mean in terms of like health safety. Like, we always obviously do the safe thing in that sense, but I mean like the secure thing where you're like, okay, we're definitely going to make our goal for sure, and we have like a for sure way we're going to do that. We're kind of more on a strategy of just, go for an ambitious target. If you don't make it, you'll get somewhere high even trying, if that makes sense.
It will be interesting to see your plan.
Right now, the plan is to, first we want to test a lot of the pieces of the rocket. So the first thing we have to do is make sure that our design for the oxidizer tank is going to be good enough to handle the pressure that is inside of the rocket. So we have a pressure test that's planned in the next couple of months here. We also need to start testing our ideas behind the propulsion, because we've never done propulsion. None of us in the group have ever built a propulsion system. So we're going to build a small scale propulsion system that's going to be about 1/10 the size of the actual rocket. And we're hoping that we'll be able to find a place to test that without going to like an expensive testing facility. Because to go to a testing facility in Germany will cost you tens of thousands of euros. and that's just not a resource that we have right now. So we're going to build a scale model to kind of understand the physics of how propulsion with a hybrid system works. And then once we've done that, we want to try and launch this small rocket somewhere in Germany. This is a hang up we're handling right now, is that we actually don't have a launch site yet that will be able to host us. But hopefully we'll be able to launch that. And that should be sometime at the end of this year, early next year, we would try to do that. Then we want to build the full-scale propulsion system. So we're going to do a full-scale propulsion test. And this will have to happen at a specific facility, probably at one of the DLR facilities. They have 2 of them in Germany that would work really well. And then once we finish that, then we're ready to kind of take the vehicle to the launch. And then one other thing we want to do in the middle is we want to do a drop test where we take the nose cone of the vehicle and we drop it out of a helicopter or a plane. And that's just because we want to test the whole recovery system in operation. We have a kind of complicated parachute deployment where we're going to have a drogue chute that deploys, and then we're going to have a main chute that deploys later. And so we need to test out how that system works. And also, like, there's a lot of weird forces that are involved with a parachute deploying, and you kind of have to test that out a bit to really understand what's going on. So overall, the goal is to try and have the final rocket ready to go, ready to launch sometime at the end of 2023 or early 2024.
So, I can tell you a bit about propulsion. We are designing a hybrid engine, so there will be a solid fuel and a liquid oxidizer. We're using paraffin wax as our fuel and nitrous oxide as our oxidizer. Will be around a 24 kilonewton engine, and our design procedure was something like, this is the goal of altitude we need to reach, so how much impulse do we need to get there? From the impulse we worked reverse and got the thrust that we need, and therefore we designed thrust that we need as well as the burn time that we chose, and from that we designed our entire propulsion system. I think our YouTube channel, the ASTRA YouTube channel, has really some nice videos explaining our propulsion system as well as in general how rocket engines work. So that would be something I would recommend viewers to watch. But yeah, that's a brief overview of our propulsion system.
If someone wanted to join your team, how could he?
I'm trying to get people to join the team all the time. What do you think the YouTube videos are for? We got to get people to come. Yeah, recruiting was actually really hard at the start. People were really skeptical of the whole idea. Right now, we mostly just post advertisements for the positions on the university resources. Like, we have some canvas boards online that we post stuff onto, and people will come sign up through that. And also through the website, you can come and sign up to join the group. We only have like 2 basic rules right now. One is that you're a student, and 2 is that you are able to be present in Bremen at least once or twice a week, because we have stuff that we're building and stuff in Bremen.
Yeah. Yeah, regarding the how do we plan to inspire others? Of course, there's like a personal journey and a group's journey with this aspect. On a more personal note, I've been on the Radio Bremen, Radio Berlin, where I try to share my experiences as a woman in STEM, and I try to kind of explain how I feel, how I got here, so that people understand that science is really for everyone. It's not for a bunch of specific group of people, but science is really for anyone who's curious, who wants to learn. And the main inspiration that we want to draw also for our team is that we do often see a lot of students getting intimidated by the fact that it's rocket science to join, but essentially there's so many other disciplines of the project that needs people from marketing, people from public relations, media, all of the finance raising. Fundraising is such an important concept that a lot of us engineers sometimes might forget because we get really excited with the engineering ideas. But yeah, the rocket runs on money, not exactly on propulsion. So there's so many disciplines, and we want to inspire all sorts of discipline-oriented students into our team. And but especially for STEM and for science, for my personal love of science, I try to do as many talks, try to get in touch with as many people, especially reach out to people who are young and awesome, just like you, so that we can, yeah, kind of watch each other grow and feel really good about the fact that, man, we're doing stuff in science and this is awesome.
And there's no age limit. You can be 10, you can be 40. If you're a student, come.
Yeah.
And we don't have any specific skills that you need to have, because as Hannah was saying, rocketry and building a rocket has so many different things that are involved in it. Like I'm sure that almost anyone could contribute in some meaningful capacity to the project in some way.
What can someone learn from joining your team?
I think the first thing we're going to learn is about the importance of fundraising, the difficulty regulations can cause, despite how amazing your plan is. um, Understanding that you really need a strong network when you want to execute anything, honestly. And yeah, there's so many other small learnings. Where do I start? I've been super happy with the fact that I'm able to put my learnings into practice. So there's a lot of hands-on experience and learning that you have. Other than this, I guess just the yeah, really good feeling of being in a team. This is something that all of us can learn, and how amazing it is to hear so many perspectives. There, we have super amazing team members. All of them really, really good at their stuff. They have a strong skill set, and they always try to make sure that their point of view merges with the rest of the team, and we have a good product in the end. Well, I don't want to say product, but end goal, that we have a common end goal.
One other thing that I think that you gain, and is a big, important resource to have in the future, is the ability to push through adversity. Whenever you're trying to pursue a difficult challenge, like we are in this situation, you will face lots of obstacles, lots of things that will get in your way. Sometimes people as well. And you kind of have to figure out how to get your way around them, and also not to lose faith in what you're originally set out to do. It's always easy to just say, oh, you know what, it's not worth it. But yeah, there's value to, when you have a team around you of people that are all kind of looking for the same thing. You can sometimes re-inspire yourself. Like I've probably had, like, I don't know, 5 or 10 times in significant ways where I've looked at this project and gone, man, what am I doing? But then I get on the call with the 20 or 30 other students that are all in this group together with me, and I go, you know what? We're doing a good thing here.
Yeah, for sure.
We can get this done.
Yeah, for sure. I guess we have to be adaptable, right? That's the main philosophy behind fixed goal, flexible plan. You might have the goal, but your plans might change. Yeah, 2 or 3 times. Just the pandemic was such a big example that you can have goals, but sometimes you're a hardware engineer and you don't have hardware access because you're not allowed to go to the office. Then you work with what you have. You work with whatever is available to you, and you try your best to just play with the parameters that are in your control and still keep the goal in mind. So yeah, fixed goal, flexible plan. This is what works, I think, for most of us.
How do you manage your team?
We have basically a plan that we want to follow. So we have a list of tasks that we want to carry out over the course of, until we get to the Karman line. We try to distribute those tasks amongst the disciplines inside of the group. So we have 5 different main groups that are part of the team. So we have the propulsion group, the structures group, the aerodynamics group, avionics, and then recovery. So each of those groups kind of has a leader, and we try to distribute the tasks for the whole rocket to each of those disciplines, and then they give those tasks to the people that are, in each of the groups. And so far that's been working. It's been working for the design phase, at least, because then it's all like theoretical. There's not really much you're doing in terms of building stuff. it's proving to be a bit more difficult as we come into the testing phase. And this is probably where Sahana becomes the most valuable.
Yeah, on the executive board, I'm the chief operating officer, yes. However, my major tasks lie around testing and operations and testing. Yeah. So it's really important for me that every subcomponent, component, subsystem, and eventually the rocket, everything is super functional. We test everything, we reduce chances of failure, and that we move ahead with confidence about our design. This, of course, comes with a lot of obstacles, like trying to get the whole team to understand what kind of short-term goals we have. Long-term goal, I think all of us understand pretty well, and we're all on board. However, setting short-term deadlines kind of becomes a bit of a challenge where we're trying to get everybody on the same page. So at times like this, what really helps is, without looking like I'm promoting, GitHub is an amazing source and a tool to use, because you get to keep track of all the versions. You get to make sure that different team members can work on your code or your CAD model or any of the documentation you're working on simultaneously, but without losing out on any of the previous versions. You don't have to waste time waiting for one team member to finish a particular part for you to take over the document. So version control is just amazing with GitHub. And another cool part of GitHub is, of course, the project section, where you have a Kanban board. You can keep track of all the problems you're having, all the short-term goals, and you can also keep track of what your team members are doing so that you can kind of align your work packages to be completed at the same time, or to make sure that your work is not kind of delaying on another person. Another source we also use is Jira, which helps you keep track control. Of course, this is meant for C coding and development, but it works pretty fine for our project management tasks as well, because you can assign a task to someone else, and then someone else is informed that they're waiting for you to kind of finish something. So some of these tools have really kind of helped with the efficiency of the teams working. And other than that, I guess the general management of a team, all of us are learning. That's the best part about this, that we're not yet in a full-time job, but we're working on a project, and it's giving us so many lessons that makes us ready for another full-time job that we're going to get later. So yeah, I've just been working part-time for 2 years at the German Aerospace Center while being a student, but right now I'm just a thesis student at DLR, and I'm also with ASTRA at the same time. So all of us are managing our regular schedules and also giving time to ASTRA because it's important to us. Yeah.
Yeah, I guess the real issue that comes in is that we're all engineers and we're not necessarily managers. So sometimes we're not so good at, I don't know, managing the whole workflow process. Yeah. I think most groups suffer from this, to be honest. I was briefly a part of the DARE group, and they had similar issues to what we have.
Yeah, and also because I work a lot with Women in Aerospace Europe. We publish white papers and we hold events there. I'm also doing another certificate program in space entrepreneurship, where we work on a Airbus challenge for climate neutral aviation stuff. And other than that, I'm constantly getting involved in a lot of hackathons. So sometimes it becomes a lot. But I feel like one project kind of fuels the motivation for another project, and this way it kind of keeps me going. So,
What projects are you doing, like, for building stuff? Like, do you do projects?
Yeah, so I've got I made different projects. Here I've got some. So I'm mostly focusing on liquid fueled rockets.
Okay.
And right now, I decided that there might be a material better than plastic to make rocket engines. So right now, I'm working on building a furnace.
A furnace?
Yes.
Okay, like are you going to build it out of steel, or what's your plan for that?
So I'm making it out of clay.
Out of clay? Okay.
Yeah, so like prehistoric furnaces.
that is pretty cool.
Are you going to try and turn that furnace into a combustion chamber or something?
No, I think so clay has this problem that you can't really do something really precise with it. It breaks easily. It's fragile. And also, if it gets exposed to water, it's not going to end very well. So I think that I will make the rockets out of like aluminum or some other metal.
Okay. Usually they the little small rockets, they build the nozzle out of clay, so it can usually be pretty good for like high temperatures and stuff. As you said, as long as it doesn't get wet.
I once made the solid rocket engines, and I always made the nozzles out of clay.
Yeah.
And there was like this weird thing that happened with all of the hot gas. What happened is because I used powdered clay, like the powder went away, and then it became
Right.
like the thing flower pots, the old ones are made of.
Mm-hmm.
And it made like a foam of that because like all of the gases went with the clay.
Interesting.
But it has to be dry, otherwise it cracks.
Yeah, that's right.
Yeah, no, I was just asking, where do you get to do all this? Like, do you have your own lab, a tiny place?
Yeah, I've got this room here.
Cool.
It's not very big, but
Do you have like some machines that you can use to work with the clay and?
So I have a hot glue gun and some scissors. Okay, so I've got some sand. I've got some sandpaper.
Okay. All right. These are the weapons of a of a startup rocketeer for sure.
Oh, okay. Well, I've got a 3D printer.
Ah, see, there you go. You have some cool tools.
Yeah.
I don't even have a 3D printer.
Yeah, me neither. And how do you manage your multiple projects?
It's sort of easy because, like, when you do something with clay, it needs a couple of days to dry, so you can do whatever you want in the meantime.
Oh,
So,
cool.
like, so for example, here I wrote this. So, for example, in the furnace, while the clay was drying, I made this fan for it.
Awesome. Yeah.
It's the importance of cardboard in my things. It's actually
Cool.
hard. It's actually hard to find like good cardboard.
We're actually looking for some good cardboard right now because we're going to for the first scale model of the propulsion system, we're gonna basically cast the grain, the paraffin wax grain, in a cardboard tube, and then that'll be like the container that it'll be inside of.
I would warn you that cardboard has a tendency to absorb some stuff, so I think you're going to have a little trouble taking the cardboard off.
We're not going to take the cardboard off. It's going to be one piece at the end. And then it's going to be put inside of our combustion chamber, and then the walls of the combustion chamber are going to be what hold it all together. And there'll be an insulation layer as well. It'll be a cork insulation layer. Yeah, the cardboard is just there to like.
Yeah, like a skeleton.
Yeah, it doesn't actually do anything.
I guess it will burn.
It will, yes, it will.
So, like, I don't know, maybe 1 kilonewton of thrust will be generated from cardboard.
If we get some extra thrust, that's great.
Yeah, the story of waiting for things to be done while you do another task actually is not very different from my life, because when I try to, so I work on FPGA hardware design, it takes so long for it to just, all the net listing and the routing, and then finally for it to run on the board. I also just go and have a coffee in between. So I definitely get the idea of being efficient while something is working to just do something else.
So what manual skills can someone learn from joining your team?
But we have some that are coming up really soon. So we're going to make our combustion chamber casing out of carbon fiber. And to do that, we have to wrap the carbon fiber onto basically like a tube. And this is kind of like a technical process on how you do this. So we are going to learn how to do that, and we're going to have lots of hands-on learning with designing a tank structure like that. We also plan to build the oxidizer tank with that same technique of wrapping a composite overwrap pressure vessel. We're going to get lots of hands-on experience with casting paraffin wax propulsion grains. This is actually something that's more difficult than it seems at first, because it seems like, okay, you just, melt some wax, pour it in a tube and then put a hole in it, no problem. But paraffin wax has a bunch of weird properties. When it gets hot, it gets all like when it's in the combustion chamber and it's burning, it'll lose like structural integrity as it gets hot, and it'll also the heat will kind of go through it, so it'll end up slipping off of the wall of whatever you cast it to, which means it'll just kind of like sag and end up going out of your nozzle as like solid paraffin wax, which is no good. So we have to add a bunch of a bunch of additives in there to make the grain more stiff, and also to modify the regression rate properties and the thermal properties that it has. So getting that right is kind of tricky and is very specific to whatever your propulsion system is. And you kind of have to play around with that. And that's also going to involve lots of trial and error. Yeah, manual skills. We're also going to get lots of shop skills, I guess, because building all of these things takes a lot of experience just working with basic tools. Obviously, we're going to use a 3D printer a lot to build a lot of the stuff that's in our nose cone. We're going to be using a lot of CNC milling. A lot of our structural components are aluminum. In the recovery bay and in the avionics bay, we are going to be CNC milling a lot of those parts ourselves. We also have 2 companies that are CNC milling the more specific parts, specifically the bulkheads for the big structure. Those are like really big pieces that are like 250 millimeters in diameter and up to 300 millimeters tall. And you can't really do that unless you have a professional CNC mill that's like 100,000 euros. So we have a company that we're going to, and they're kind of walking us through the process of how you're supposed to design your part in order to actually allow the mill to actually manufacture it. That has definitely been a learning process, because like you think it's like obvious, like, okay, you just submit your 3D design to them and they manufacture it perfectly as you thought in your mind. But there's like a drill bit that's going in and actually making all of those cuts and stuff. And there's a whole bunch of extra things you have to think about, because there's actually a physical part that's going in and doing all this cutting and stuff. And there's some things that you design that are actually physically impossible to make. So, thinking about that's also something we're learning how to do. We've gone like back and forth with the machinists over the last month, like 5 times, with different designs going back and forth. And they keep telling us, no, that's not possible. Try again.
Yeah. Maybe they don't quite count as manual, but still they're essential skills. I can speak for the avionics and electronics aspect. People have all worked on different experiments in their lab or school projects, but interfacing with real life problems, interfacing with other departments of the rocket. So this is a basic skill I think everybody had an idea of, but kind of optimized after coming to the team, where how can I make sure that my avionics does the job that the recovery needs? How can I make sure that my sensor really interfaces well with this other structural aspect? So I think one skill for sure is the aspect of building printed circuit boards, interfacing different sensors together, ensuring that everything that you do fits with the mass budget, the power budget, and all the restrictions probably the launch site will place on your rocket for how it should be. So these are definitely also some skills that people kind of had, but really got a better hold of after coming to the team, because what's you know better than us that you need practical projects to actually pick up these skills instead of just school.
Yeah. And also, one other point I will add is you also have to be a bit creative with how you test things as well. So in regards to creating your own tools, I would also add creating your own test beds, because you can save a lot of time and energy by designing a really smart test that tests the thing that you need to really look for. So for instance, we are worried about the recovery bay and the avionics bay surviving the G loads when the parachute opens up. so we've decided to create this test bed where we're basically going to drop like a big weight that's attached to the whole frame of the avionics bay and see if it survives. And so we've built this like really like, we just went to the hardware store, bought some wood and stuff for like 50 euros or whatever, and hammered and nailed together this contraption that will basically do this test for us at a discount rate. And you'll probably see about that on our channel in a month or two, because it hopefully has some good results, or maybe some exciting ones where the whole frame disintegrates. I don't know. We'll see.
You have a good YouTube channel.
Oh, thank you.
You're welcome. So how do you manage your communication?
Like, you mean how do we manage the communication on YouTube or on everything?
Like in general.
In general, okay. Well, we have a marketing team at the. I forgot to mention that when I was telling you about the teams. There's the 5 of that are doing like engineering work, but there's also a couple of teams that are doing other things that are trying to. Like, we also have a project management team, which is doing all the paperwork and stuff for the group being an EV, which is like a non-profit organization. We also have people inside the project management that are actively doing jobs for recruiting people. We also have a team that's, like I said, the marketing team. We also have a legal team. It only has 1 person, but it's still technically a team. And we have a finance team as well, which is kind of a mix between the marketing team, and they're responsible for like doing the taxes and the managing the bank account and stuff like that. In terms of the marketing, though, like the marketing is a whole bunch of people that are contributing to it right now. Like, we have people that are helping out with, like, on the YouTube channel with animations. All of the people who are even in the engineering departments, I'm trying to get them involved in terms of doing interviews with them and incorporating them into the marketing campaign, because I think that the best way to publicize about the group is to talk to people that are in the group and get to know what they're designing and what they're working on and what they think, because I think that's what will catch the attention of people who are maybe interested in joining a group like this, or maybe just interested in science and technology and wondering what they're going to do next in their life, or maybe they want to pick a major or something. So it's not just about publicizing the group so that we can, get sponsors and stuff. It's also about trying to show people in the world that the rocketry is interesting and exciting, and that there's lots to learn and there's lots to innovate in this area. And if there are young people such as yourself that are excited about rocketry, I want to keep them excited about rocketry. Because I feel like a lot of people who are excited about this stuff when they're young, everyone wants to be like an astronaut when they're a kid or something, right? But then that kind of fizzles away as you get older, because people, I don't know, they realize that, oh, well, space is far away and I have problems in the world right now. And, oh, I want to just do a job that makes me lots of money. Something like that. And, I want to try to keep that fire of looking at the world and trying to see the mystery of it. I don't know how to say that properly. That
keeping curiosity alive.
Yeah. Exactly.
Mm-hmm.
Yeah.
And space is for everyone. In the end, it shouldn't be for like anybody specific. So it's important that we reach all sorts of audiences, not just one particular domain or kind. So when there are videos from different branches, I guess someone who's super into sensors will be interested. But at the same time, someone who's just doing a full-scale CFD analysis is also interested. It's a bit for everyone. And yeah, that's how you keep people engaged. It's how you remind people that we're kind of all in this together and there's someone you can relate to online. And that's great, right?
Yeah. Ultimately, now I'm going to start sounding crazy, but this is what you get. Ultimately, I think it is imperative that humanity continue to invest significant amounts of resources into trying to develop space technology and ultimately to make humanity a spacefaring civilization, because that is a destiny that, first of all, is exciting, I think, and I think lots of people think that's exciting too. I could be wrong, but also it's important because it's like the natural next step for the progression of our technological society. And if we don't invest the resources now, sometimes I'm concerned that we may lose this opportunity in the future, because of world craziness. So yeah, there's a little bit of there's always that in the back of my mind as well. And yeah, I think that I would hope that any sort of PR or social media presence that we have, I would hope that inspires some people to think about starting on this path of becoming someone who wants to work in engineering and science and technology.
Yeah, it's like a launch window for innovation right now. Yeah.
Yeah, exactly. It's a really cool time that we live in, I think.
How much time and resources do you dedicate to making YouTube videos?
Oh man. Getting in with the tough questions.
Yeah.
Too much. I wish it was easier. Yeah, I mean, I guess it depends. It can be hard sometimes because of like anytime there's something that has a lot of animation and stuff in it, then it's going to be hard because that takes time and energy to make. We're not very good at doing this kind of stuff. I know you've interviewed some people that are really good at it, but this is not our strength. Yet. Maybe we'll get better. I don't know. Right now we just do some small things in like Blender, and I have an Illustrator account that I use to make graphics and stuff. I make all the videos right now in Lightworks. That's what it's called. But yeah, if you put it all together, like to make one video, if you count, I don't know how you want to count the man hours, but it probably takes like in total probably like 30 or 40 hours amongst all the people that have to be involved at each point.
What about you? Do you make all of it on your own, or how much time does it take for you?
Yeah, so recently I'm doing these videos, which are interviews. Once upon a time, so I did like Minecraft and Kerbal. And those were practically, it took the time to make them as the time the video length was. So like if the video was like 10 minutes long, I probably spent 10, maybe 20 minutes making it. Not that much because it's simple, but I understand that with animation, it's not that easy.
No. Also, even when you just do interviews, like when we're interviewing the different people in the team, like we'll have like a studio set up, and we'll have like to set everything up takes time. We have myself, the person we're interviewing. We also have a cameraman who will be operating because we'll have like 3 different cameras that are all at different angles. And then we'll do the interview for like an hour, but of course I can't upload a whole 1 hour video to YouTube because no one will watch that. If it's like super long and we're just talking about technical stuff, you sometimes have to find like the interesting parts and try to
just our
condense
videos.
it.
Our videos.
Yeah, for other people, like we're not a what do you call it, podcast type channel where we're doing these interviews where it's like long form. So because we're a short form channel, we have to kind of cut these things down to make it, I don't know, more like in the style of how the rest of the videos are on the channel. That takes time. Like editing a conversation is really more work than you think it is. And syncing audio with video is a nightmare.
And then multiple camera views as well.
It's yeah. It can be annoying.
How is important the public relations department for you?
The problem with rockets is that they're expensive. So, like just to build like even just small rockets that are not going super high, like 3 kilometers or 9 kilometers or something like that, that can cost you tens of thousands of euros. And we're students, so we don't have tens of thousands of euros just lying around. So how do we get that money? That's the question. And this is where the PR comes in, because basically, if people don't know about you, they can't support you. So the goal of the PR team at ASTRA is to get wider exposure to the world and to people that are interested in supporting rocketry and supporting cool projects like this. And that can be from just regular people, that can be from industry, from companies that are looking to support groups. It can also be for people and industry that is looking to maybe get some advertising or try to connect with students so that they can maybe have some potential recruitment bases in the future. But yeah, if people don't know about who you are and you don't have that exposure, then you can't get access to those kinds of funds. So this is why PR was always important from the start for us, because we knew this, and so we're really trying to focus on making sure that we can maintain a revenue stream so that we can keep the project going. Yeah, at this point, sometimes it feels like we are a marketing company that also makes rockets. But yeah, well, sometimes that's a bit challenging.
How do you finance your team?
So right now, we don't have a lot of finances. So it's mostly just been personal donors that are giving to the group right now. In the future, we're hoping to get some more professional sponsors that might be interested in sponsoring the team. So there's two or three parts to rocketry. One is actually building the physical pieces. So like the carbon fiber, the aluminum, the sensors, the electronics, the valves, like all of those physical pieces cost money. But the nice thing about this is that usually commercial companies are pretty excited to sponsor, to give you material, because if their material is part of your rocket, it's kind of like free advertising for them. That, oh, we flew to space. So
Yeah.
we have lots of sponsors already that are providing material for free. So that part of the rocket is kind of more or less, lots of the expensive parts are covered.
Also, sponsorship comes in terms of like facilities needed for you to work in. There's Hackspace. It's a tiny part of BIBA, another institution at Bremen, who is offering their space for us to work in, which is amazing. And essentially, we get a lot of access to materials, sensors, electronics. This is also sponsorship, like, having a place to work in, having a place to integrate your stuff. These are all there from multiple places, and actually I count that as a win for us, for sure.
Yeah, we have right now. We think we have two places that we're building stuff. So at the BIBA, but also we have another place called the Fab Lab, which is in Bremen. And they didn't sponsor us completely. They just gave us a really cheap rate. So yeah, the facilities, also the facilities to test is really important, because testing is really expensive. So we're trying to pursue ways that we can find test facilities for cheaper or for completely sponsored at the DLR or maybe some other places.
Yeah.
We're trying to use our connection with the DLR to kind of make that work. This is where Sahana's skills come in a little bit more.
Yeah, as you know, we also have to do reviews, and reviews also come at a cost. So luckily, we've had a lot of supportive colleagues of mine from DLR who have offered to do these reviews for us. And this also is a form of not exactly sponsorship, but let's say goodwill that's helping the team out quite a bit. And we had our own booth at the Space Tech Expo last year. I think this was like a really great way for us to kind of raise awareness about us, reach out to people who have materials. Some people probably wanted some part of theirs tested, and then we wanted to take some parts of theirs for our structure. So we made a lot of contacts and met a lot of people, and I think this helped quite a bit for us to understand what we have and what we don't have also.
We should also point out that that spot at the fair was also sponsored.
That is true. That was a fully sponsored spot. Thanks
So,
to
it's really cool. If you kind of just reach out to people, you might get you'll get some no's where people are like, no, we're not really interested, but you'll get some yeses too, and you have to just kind of follow the yeses up and work with what you have. So yeah, for only being around for a year, we actually have a ton of people that have supported us already, and that is really really cool. So yeah, I don't know. I think that the list of sponsors will hopefully grow lots in the future, and our whole rocket will be covered by all the different logos.
Yeah. And with respect to the European outlook on all of this, I think with the Space Tech Expo, it was really clear that Europe wants to be in the forefront with the space activities. Unfortunately, COVID definitely affected a lot of people. However, seeing that there's a common goal all across Europe that we want to put Europe in the forefront with space activities, it's been pretty helpful that you have reached out to more partners, more sponsors. We also had Altair give us a lot of material for software and to train our teammates with. There's a bunch of softwares that Altair provides also with training material with respect to simulations, analysis of the structural parts, model-based engineering, too many courses that they offer.
Do you learn entrepreneurship if you join your team?
I think the whole team is entrepreneurship essentially. it's just the idea of you have an idea, and then you have to go figure out how can we make the idea happen. That's essentially entrepreneurship. The only difference is that obviously the group is not trying to make a profit off it. It's just we're doing it because why not?
Yeah.
Yeah.
For me, I think I was pretty lucky with a few opportunities I had. I pitched an idea of on-orbit servicing with a team in Actin Space 2020, and we won Actin Space 2020 Sweden. And we had an ESA BIC and so European Space Agency Business Incubation Center and Arctic Business together gave us an accelerator program. I think here I had my first steps towards understanding entrepreneurship a bit. And right now I'm also doing the space entrepreneurship course with the European Institute for Innovation for Sustainability. So I think I have a few parts of learning coming from institutions, but I get most of my learning from practical experience at ASTRA. And when you kind of combine the two, I think it really helps to kind of take things forward, to see how can my learnings come together and help this particular situation to help us move forward as a team. So yeah, there's still definitely quite some learning at ASTRA.
I think there are a few things that when you say entrepreneurship, that people don't immediately associate with that. So when you start a company, there's a whole bunch of things that have to happen that you probably haven't thought of, and that's what we're doing at ASTRA. And there are things that I hadn't thought of as well. So it's number one, you have to do a bunch of paperwork because you have to make your company real on paper with the government, and well, that takes time. There's a whole process you have to go through, especially in Germany, and we love our bureaucracy here. So we had a problem with the office, the tax office, because what we did is they wrote ASTRA as a big A and a small STRA, and that's what happened when we signed to the notary. But then when it went to the tax office, they noticed that we're actually big, all caps ASTRA, and because of that, they were like, no, you have to go back and re-sign all the paperwork. So it's going through those processes where you have to deal with this kind of bureaucracy, and being careful with things that you start to learn as well. There's also a whole financial end to it. You have to do taxes. You have to keep records. You have to set up a bank account and run a bank account, and figure out ways where, because you have multiple people that have to access the bank account, you have to establish protocols for, well, how are we allowed to use it? How does it work? What are the rules? We had to make a whole bunch of rules for how our nonprofit works, or it would also be for a company. So we have rules about like when we were voting on who's on the board, how are we allowed to implement certain rules and regulations for the EV. There's a whole like process and procedure for how to do this type of stuff, and learning how to do that I think is really important, as if you want to be an entrepreneur, because you have to go through all that stuff. And we have board meetings, and we have just regular things that you would have to do if you were establishing a company. Yeah, the next part of it that is really important is how do you expose your idea to the world, right? So you can have an amazing idea, an Elon Musk idea, but if no one knows about your idea, then it's no good. So we had to learn how to, and I think we're still learning. I don't think we're very good at this yet, of how to do PR. How do we connect with people who are able to help us, to support us in our idea? I think those are like some really important things you have to learn on the entrepreneurship path, and you really have to try it out to really understand it.
Okay. Could you give a recap of the Transcendence rocket mission?
Yeah, so basically we have our rocket here on the test stand, or launch stand, and then it's going to launch. It's going to have about a 15-second burn duration, and the thrust that it's going to have on takeoff is going to be about 24 kilonewtons. We wanted to keep that duration as short and as possible, because we need to get really fast off of the tower so that we're not affected by the wind so much. You'll also notice that the rocket is spinning, and the reason for that is because we want to have spin stabilization, and this will damp out a lot of the perturbations that happen during the flight from things like off-center thrust and wind and other types of perturbations. Once we reach the Karman line, we're going to separate the vehicle. So the booster half will go away, the nose cone will be on its own. The reason for that is that we have a really small parachute to save on mass, so we don't want to have to take the extra mass and systems we would need to recover the entire body. The body's really heavy, so it's nearly 100 kilograms, so that would be like a really big parachute we need to bring all that back. And then the nose cone will basically fall all on its own, back down to Earth. It goes really fast when it does this. It comes up almost to Mach 3 as it's descending, so this is why we need to first open a drogue parachute to kind of slow it down to a speed in which we're able to open up the main parachute. The drogue parachute will deploy roughly at about 5 to 10 kilometers. We're not really certain on the exact altitude yet. And then when we slow down the payload to a reasonable velocity and we've come down a bit more, we open up the main parachute. And we just want to reduce the amount of drift that the payload will experience, so we try to open that main parachute as low as possible. And then yeah, we'll land either in the middle of the woods somewhere in Sweden, or somewhere in the ocean if we have an ocean launch site. So it could be a wet recovery.
Yeah, and of course we want to check the apogee, and once we recover, there's going to be a beacon on it to ensure that we can find it, and we want to check what altitude we went to and how the sensors functioned when we get the black box back. Yeah.
How close are you to reach space from 1 to 100?
Oh man, maybe like 13. I don't know. We haven't really built anything yet, so you have to keep that in mind. A lot could change. We could think we're at like 50 when we're actually at 10. So yeah, it's hard for me to say exactly where we are. If we had once we start testing in a couple months, we'll know more where we are. Because if things are working and as we expect, then we'll actually be quite far down the path. If something is very vastly different from what we expect, then we could be coming back to the design a bit more.
Instead of an absolute answer, I think at this point it's going to be the rate at which we can kind of increase on that scale. It's going to be pretty high with reviews, pretty much higher with the testing. So I think the growth rate is going to be faster because we have an ambitious goal in the end. And yeah, it's not about where we are right now, but I think where we will be in a little bit of time. Yeah.
Yeah. So in the scale you have here, you're saying 1 is a water rocket and 100 is a Karman line. I would say we're probably going to be somewhere near a 10 to 15 in a couple months, because that's when we're going to have our small scale rocket demonstrated. Yeah, orbit is definitely 10,000. Yeah, that's about right on that scale. In terms of the propulsion that we chose hybrid, which is maybe a curious choice in terms of like how hard it is to build and stuff. Obviously, it's really whatever propulsion system you choose, it's always going to be difficult. I think the more conventional route is to go with solids, because you can actually build a smaller vehicle with a solid design, because you only need to think about one tube, put the solid propellant into it, and then that's basically your rocket, and you can send that up. So in terms of like design complication, it's much simpler to think about and a lot simpler to design, because all of the variables inside of that are known. Like you can a lot of times the propellant grain is like the regression rates are all known. Like you can read about them, and you can kind of just implement the same type of strategy. So you can kind of start at a design phase and end up at a solution, I think, quicker because of the experience that's there. With hybrid, it's a bit more difficult because you have a fluid that you're dealing with, and the behavior of that as it flows into the combustion chamber can be quite complicated. So there's a lot more testing, I think, that you have to do in order to make sure that it's performing the way you expect it to. Yeah, there's that. And I think that complication is probably similar to a liquid fuel rocket. Liquid fuel tends to be a bit more complicated, though, because now you have two fluids that are flowing. But I don't know, depending on who you talk to, sometimes hybrids and liquids, some people would say, no, don't even do hybrid. It's not even worth it. Just make a liquid one. In terms of multi-stage rockets, I think that's something you need to be a little bit more experienced with before you start playing around with, because lighting a rocket is actually more complicated than it seems. And lighting it while it's flying is vastly more complicated. Yeah, that's like, imagine trying to ignite a lighter while traveling on the highway at 100 kilometers an hour. Like it's a bit difficult.
Where do you want to test your rockets, and where do you plan to launch them?
Of course, this is subject to change and subject to availability with respect to time slots. As you can imagine, when we're going to a commercial agency or an entity, we kind of don't get as much priority as previously booked slots for testing. So essentially, we hope to test with the German Aerospace Center sites in Traun or in Lampothausen. Of course, this is not set in stone. Nobody's promised us anything. This is just the desire that we have, that we want to test with them. Regarding launch, we're looking at a few launch sites. One is the S-Range launch site, of course, from Sweden. We also have Spaceport 1 and Shetland Islands. Maybe Josiah can talk a bit more about them geographically. So these are just with respect to propulsion and launch. However, there's a bunch of other tests that we have to do along the way. We have to make sure the avionics works really well, and that we definitely have some kind of estimation with the altitude and the functioning of the sensors. And for this, I think we can perform a lot of tests in the hack space, which I mentioned previously. Recovery plans to also look for permission for flying the aircraft somewhere at different altitudes of up to 2,000 to 3,000 meters to test the drogue and the main chute. We want to do the pressure test, of course, which again, hopefully supported by the German Aerospace Center. And there's also a couple of test sites that we're looking for vibration tests. One is in ETS, European Test Services in Netherlands, and the other one is also DLR in Bremen. So yeah, we have a few options and a few possibilities, let's say, and a lot of interest to test them. And in the end, we're going to have to see which dates work out with which facility.
Yeah. It can be a little bit challenging to find a good place in Europe, just because it's kind of similar to what I said before about it being so populated. If you want to do anything propulsion related, one thing you always have to think about is noise. The neighbors don't like it when you light a rocket in their backyard. Rockets usually have about 140 to 160 decibels of noise, so you can hear them from quite a ways away. Yeah. in other places, maybe you can sometimes get away with this because it's remote, so you can do it somewhere where no one is, and then it's not such a big deal. But for the geography of our launch sites, if you want to launch a rocket to go to 100 kilometers, you're really restricted to where you can do this. The downrange distance that the rocket will travel is nominally about 50 kilometers, and it could be as much as 100 kilometers. So you need to have a launch site that has like that much area where there is no people. So you can't really do this anywhere in mainland Europe. There is the only launch sites that we're really aware of at this time that are really able to host this type of stuff are all in Scandinavia, or in northern United Kingdom, or in southern Spain, anywhere where they're kind of like where they're going over water or over a really remote area. For smaller launches, you can find some places that are potentially suitable. So in Germany, usually you can get stuff. You can launch something that maybe goes less than 5 kilometers. I know that High End launched one of their small scale demonstrators at a military range in Germany, and that went to about 3 kilometers. But you need to be connected with the military to get something like that happening, and we're working on that right now. So if the Bundeswehr is listening, please let us launch our rocket at your sites.
Yeah, we're just students wanting to do research, so essentially it would be great to have that. For example, for the place we're in, there are a couple of airfields that allow up to 1 kilometer and 1.8 kilometers maximum if you go 40 kilometers from here. They're all airfields for model rockets or any experiments, but as you can imagine, this is not as useful for us to launch to 1 kilometer. So we do need to get to a place, we do need to get clearance for a higher altitude. I think the major problem is, just like Josiah said, quite some population across a really small area. And Germany is pretty restricted with respect to dropping stuff from the air, with respect to launching both. So in order to keep in the boundaries of the regulation and still meet our goals, it is quite a bit of a trade-off.
Have you ever tried to design a rocket yourself, and launched it?
So I made sugar rockets, and I built them. If by designing you mean like making a computer file?
No, I mean like building it out of materials and going out and launching it.
Yeah, so I have made some out of cardboard, and tape. Those are the two things I do. And it's difficult to say how high they fly because, of course, I can't put a sensor on it.
Yeah.
Because they are things kind of like this thick, and high above like this.
Okay.
So there isn't really space for a chip, not a chip, a motherboard and some sensors. But just guessing, I think I've went over the 500 meters.
Oh wow!
That's pretty cool.
With just a little one like that, that's pretty amazing.
What you could try is maybe get a Raspberry Pi hat. They are super small, can still fit in your model rocket, and maybe put an infrared sensor just to check how far up you went, or put a tiny Pi camera, also super small, and that with some image processing estimations, it could be possible. Yeah.
I was thinking of using a triangulation, I think it's called. Where if I have this surface and I know the rocket went like this, and I know this is 30 meters, well then I can take a photo, for example, and I can see the angle from here to the rocket. And using some calculators that I found on Google, I can find how high the rocket went.
That's what amateur rocketeers do when their sensors fail. they take a look at the footage of the video and they see which mountain they could see, and they're like, well, you can only see that mountain from about 9 kilometers high. So we think we went to 9 kilometers.
Yeah, but image processing in general is a really powerful tool. So it sounds great that you're trying to do that, because you don't need super sophisticated algorithms. Some of the greatest ideas are always the simple ones. So definitely looking forward to, at some point, you may be showing us that you estimated the height. Of course, I'm also really excited to help if you want to talk sometime about it.
So how do you design your rockets?
The key thing is to start with your requirements. So what do we want to do? We want to build a rocket that goes to the Karman line. So then from there, we work back to what do we need? What do we need in order to get that goal? So in rocketry, usually when you're designing a system, you want to figure out how much like delta V you need, or how much impulse you need. And that's basically the amount of energy that your rocket has to have in order to overcome the gravity and the aerodynamics to get to the destination. So from there, you can start thinking about, well, how big does the rocket have to be in order to achieve that? And that's kind of like the design part where you're just thinking about it in your mind. And then from all of that thought, you'll kind of come to a preliminary design where you're like, okay, well, I think that if we use this material and we use this fuel and we use this system, that we'll get this far. Then you have to start moving into the real world and say, okay, is it possible for me to build this structure with this fuel and this system, and can I actually do that? So we've gone through this loop a couple times where we're like, okay, we want to do this, and we think we can design. We've designed this thing. We go to the real world and we're like, oh shoot, that's actually not possible. We've done something silly, and then we have to go back and say, okay, let's go back to the real world. One example of this is initially we were thinking of using rivets to put our structure together. A rivet is it's like a bolt, but it like you can fasten it. You can put it in on one side, and then it there's a mechanism that causes it to like keep two pieces together.
Oh, so like a nut on the other side.
It's like a self-forming nut. You don't need to do anything on the back to make it. Like you push it in, and then it like sucks out a piece. It like sucks out a piece of it, and it forms a secure thing on the back.
Okay, how's it called?
It's called a rivet. RIVET. It's commonly used for things like boats and stuff, for putting structures together. It's really easy to use, and you just have this like rivet gun, and you just go boom, 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 and then you can fasten things together. And we thought, oh, this is amazing. We'll just rivet the entire structure together. It'll be super easy. But then we figured out that, rivets are actually not very waterproof or pressure proof. So that won't work at all. So that's kind of how we go through this process of trying to figure stuff out. We also made a little like model rocket thing that we took to the Space Tech Expo as more of an expose of showing what the whole thing will look like. But it's also important to do little things like that to start thinking about the problems that you're going to have when you actually try to build the real thing. And one problem that we experienced when we built this little scale model was that basically we 3D printed our bulkheads, and we bought like these PVC tubes that were going to be like our carbon fiber structure. And when we tried to put them together, of course, we did all the math before, and we said, okay, they need to be this wide and this big and everything. But when the machines actually made them, they were a little bit off. And so we tried to put them together, they didn't fit. So then we had to sand them and like make modifications to make it so that they would fit. And that made us think like, okay, when we actually build these parts, we need to also be thinking about that. And we need to make sure that our tolerances, or making sure that they're a certain width or a certain size, are really precise and the way we expect them to be. And you can't, and of course you can know that beforehand, but you need to have experience. And so if you do a little small project by building like a little tiny model version, you can kind of learn about, okay, what are the problems that are going to be there with your design when you try to put things together.
All prototyping starts with the design process. For this, we are using a program called Fusion360, which is a freely available software for all students. Our plan is to 3D print the main components of our rocket, which include the upper bulkhead, the middle bulkhead, the nozzle, and the nose cone. These pieces will then be fit onto the combustion chamber and the oxidizer tank, as they would be on the real rocket. We chose to 3D print these parts as they have complex geometries. For the real vehicle, we'll actually not be able to do this because 3D printing aluminum is quite expensive. Instead, we'll probably end up CNC milling, which is a reductive process instead of the additive process, which 3D printing is. A 3D printer is basically the magic wand of engineering.
What fuel and oxidizer do you want to use?
Yeah, so we are going to be using paraffin wax for our fuel, and then we're going to use nitrous oxide for oxidizer. And the reasons for this are that, first of all, paraffin wax is a really nice material to try for fuel. It is easy to acquire. It's super cheap. Like, it's just candle wax, so you can get it like anywhere. It's also super easy to work with because you can just melt it and pour it into things, and you can cast any kind of shape. So that's nice. It also has a special property, which is that it burns really fast. So because it has a low melting temperature, instead of it like kind of burning away where it goes right from a solid into a gas and mixes with the oxidizer, it actually kind of, there's a layer that forms on the surface of it where there's like a liquid that's being injected right into the flame. And because it's going into the flame as a liquid, you can get way more of it into the flame at once than you can with other types of materials. And this means that you can get really high pressures and really high thrusts, even if you don't have that big of a system. So this is a really nice property, and that's why we chose it. For the nitrous oxide, we chose that because it has a self-pressurization effect. So we don't need like an extra pressurization vessel with like helium or nitrogen that pushes the oxidizer into the combustion chamber. It'll actually just push itself into the combustion chamber because of its properties with how it's stored at 55 bar when it's in the oxidizer tank, and when it flows into the combustion chamber, it just kind of maintains the tank at 55 bar because of evaporation. It's a bit complicated to think about, and it actually took me a little while to wrap my head around it. This is something that I actually just learned about last year, so when we were initially designing it. So yeah, we'll see how well it works in practice.
Now that you've had your mind wrap around it, now time to wrap some carbon fiber around it.
Yeah, exactly.
Yeah.
One problem that we are potentially anticipating is that nitrous oxide and CFRP have a history of not necessarily being super compatible. So yeah, we're definitely going to need to test our tank to make sure that it is going to be able to handle the nitrous oxide.
Mm-hmm. And also we have to watch out for the aspect that all of the nitrous oxide stays in the gas state and not moving to liquid just for fun, just to mess with us, and then condensing on the valves or something and causing issues like freezing stuff. This is also something we'll have to watch out for.
You're always worried about the freezing on the valves, Sahana.
Yeah, it's only been 3 teams who complained of this, so yeah.
Taha just wants to put heaters onto the tank.
What could possibly go wrong with that now?
Heaters and rocket fuel. What could go wrong?
Yeah, no problem at all.
I think the carbon fiber isn't really airtight, so I think you should use like some metal something.
Yeah, so that's a good point. Some groups have done basically an aluminum liner that you put into the tank. So basically, you create this aluminum tank, and then you wrap the carbon fiber around the aluminum tank, and that makes your tank. The lab that we're going to be building the CFRP tubes at actually has some experience with building pressure vessels that are only CFRP. So we're kind of relying a little bit on their experience with that technique to inform the design of our tank, which will also try to be just the CFRP piece in the middle. And the place that we've been doing this with is called the Faser Institute, and they actually have made pressure vessels that contain helium that are just CFRP. So we are, because of that experience, we're a little bit confident that we'll be able to do it. Of course, it's always subject to testing, so we'll see what actually happens at the end.
Do you plan to use thrust vectoring?
Oh man, yeah, this is definitely beyond our capabilities at this point, I would say. To thrust vector a 24 kilonewton engine is quite a challenge. I don't know how to imagine this. Have you ever, I don't know, have you ever seen like a fire hose or something? Like for a fireman when they have the big hose?
No, but I know how it works.
Yeah, well, anyways, if you've ever watched them try to handle it, they basically need like 3 guys holding on to point this thing because of all the force that is made when the water comes out. So if you think about like how much like power you need to push and pull on a rocket that's shooting out at 24 kilonewtons, which is way more than that fire hose. Yeah, there's like a lot of mechanical muscle that you need to do that. And it has to be precise too. And so being precise and powerful, that's a challenge.
Do you use trapezoidal fins? And if yes, why? If no, why?
Oh, we're really getting into the weeds now. Yes, we do use trapezoid fins. The reason why we use them is well, first of all, they're really good for traveling at Mach speed. So usually when you have like a wing or something like that, like the classical wing shape, that is really good for when you're going below the speed of sound. When you go above the speed of sound, there's lots of like shock stuff that forms on that wing surface, and it creates some complicated airflows, and you get weird stuff that happens with like flow separation and stuff. And then we want to stay away from that because you get like, yeah, into weird stuff. The trapezoid fin is nice because you have like this sharp point that is going forward into the airstream, and that is going to be something that works really well for getting through the sonic boundary. And also when you get into the hypersonic regime, it's good for the drag coefficient that the fin has. The next point about the trapezoid fin is that we're actually planning right now, temporarily, testing phase, to have an asymmetrical trapezoid. And the reason for that is that we want to actually use that to create lift on the fin so that we can produce spin. This is one theory that we have for how we can get the vehicle to spin so that we get the spin stabilization. We might choose to abandon that later on after we do the subscale test if we find out it doesn't work very well, and go with actually just angling the fins to create the spin. But we'll see which strategy is more effective.
Do you use PCBs for your rockets?
Yeah, this is a really debated topic with the aspect of how much we should have a trade-off between existing components and making custom boards, because custom boards are always subject to conditions that they didn't have before, because of which they might fail. You might have wires coming off, you might have connections not staying stable. However, the idea is to use. At this point, we are testing out different routes. One idea is what I mentioned about the Raspberry Pi. So Raspberry Pi Hat is another kind of daughter board that you can attach on top of the normal Pi that you always have. And the cool part is that it has a sensor for height, pressure, and IMU all as part of it. Another aspect to also keep in mind is the battery system we have, because we wanted to stay alive to the point where there might be delays while filling, and the onboard computers shouldn't die with this time. We also needed to be functional to the point of the end of the flight, and also to the point where we go and find the beacon and recover the avionics. So battery is a concern that we want to think about. Of course, the prime objective of ours is to find if we the 103-kilometer mark, the altitude, and anything else we can get other than that is really like a bonus on the way. So we do plan to have a camera. We do plan to have IMU sensors. We plan to record the altitude in more than just one way. We also want to make sure that we have a good way to lock with the GPS coordinates to ensure that we've reached the right altitude. So yeah, we are testing different possibilities. We definitely have the idea of having our own custom printed circuit board, but we also want to check the Raspberry Pi hat that I mentioned. And the main idea to keep in mind is actually the trade-off between computational power and the complexity of the algorithm that's running on it. So we want to really keep the design simple so that we give as much power as possible for the sake of tolerance until we find and recover the avionics.
How do you want to recover your rocket?
The main idea is, of course, to have the drogue parachute deploy, and then the main parachute, and eventually to have a beacon that helps us locate the avionics system for us to go recover it. Ensuring that the parachute's not getting tangled together. I'm not sure I have an answer to that.
Well, the two parachutes are stored separately, so they shouldn't become tangled in any way. The first the drogue will get deployed. It's on the upper part of the recovery bay, so it'll get kind of shot out into the airstream. And there's like a system that keeps it so that only it is deployed well in that phase. And then we have a pyrotechnic charge that's going to fire, that's going to release a pin that's going to pull out a cord that's connected to the main chute, and that the drag that's on the drogue chute will essentially pull out the main chute. So I don't really foresee that they will get tangled. What could happen though is that the lines themselves, the lines that connect the bay to the parachute, that could become tangled on something as it comes out of the parachute bag or something like that. And that's why we need to test the deployment and how that works, and why a drop test is really the best thing, because that's putting it in its natural environment and seeing what will happen. One concern I do have though is if the nose cone is not in the nose down configuration, it could be challenging to have the parachute come out without like the nose cone flying into the parachute. Like if it deploys upside down, yeah, that could be a problem.
But of course, we plan to add some dummy weight or ensure that avionics has redundancy. So like instead of one pressure sensor, you have two, to make sure that if this fails, the other one works. So by adding a bit of redundancy or some weight in the nose cone, I think it would be a good way to make sure that it is pointing nose down when it's landing.
Yeah, but having a perfect recovery is probably the hardest thing of the rocket, I would say. Yeah, it's always the part where amateurs get, I would say that has the greatest difficulty in terms of making it work properly. There's just a lot of variables when it's coming down to deal with.
Do you plan to use air brakes?
Well, I know this is a part of how EuRoC rockets usually are designed, because they want to get a precise altitude. So obviously when you make a propulsion system, sometimes it's a little too powerful. I usually want to go on the side of too powerful, so you're for sure going to get to the target. But then as you're flying, you may want to adjust quickly, maybe have some more drag to slow you down so you'll get right perfectly to the target. And that's when these air brakes work really well. But of course, for our rocket, we're just trying to go as high as possible. So no need for ascent air brakes or anything. We could use them on the way down, but we actually were briefly considering them as a way to slow down the nose cone instead of the drogue chute. But in the end, it turned out to be more mechanically complicated than just having a drogue chute. So yeah, briefly considered, but then thrown away.
What's your payload?
Oh man, we wish we had a payload. If anyone wants to ride with us, let us know. We don't really have an official scientific payload yet. We have our sensors that are going to go up and take data, which will be interesting and useful because, I guess not a lot of student rockets have done that, and at least the data will be useful if someone wants to ride on a rocket like that in the future, because then we have a bunch of data that says, well, this is what it's like to ride on it. So this is what your payload has to be able to withstand. It's quite a violent ride, though. Like the rocket will experience, I think, 16 or 17 Gs is the latest simulation we had of force when it lifts off. So that's quite extreme.
Yeah,
so nothing
looking to extreme test something for sure. Yeah.
Nothing sensitive on our rocket for sure.
Do you like and play Kerbal?
No, just not as often as I'd like. But yes, I definitely do play. I think it definitely helped me get a better feeling for, let's say, the whole facility in one place, for example, because you have this integration facility where everything you want is kind of in the perimeter. And usually a lot of these integration facilities are very access restricted. So I don't get to quite see this on a regular basis. So I think kind of seeing the big picture together, seeing all the subsystems fit together is a challenge for any engineer, because an avionics person usually works in an avionics lab, and a propulsion student usually works in a propulsion department. But in Kerbal, I really like the idea of how you can see all the subsystems together. And this definitely helped me kind of see, okay, this particular software-defined radio platform that I'm working on is going to fit in this section, and it's going to be useful in this part of the operation of the mission. So yeah, definitely helped me a bit to get a better idea about the whole idea of rocketry. It was in Kerbal Space Program. I think I exploded too many times trying to get to the moon with thrust vectoring. This was not a skill I had. I don't know if it's my lack of hand-eye coordination, controlling the roll, pitch, everything together. I kept exploding so many times. So I can only imagine this is much worse in real life. So
I know if you in Kerbal Space Program, if you press T, you have SAS. I don't know what it stands for, but it's like it helps you stabilize the rocket.
mm-hmm.
Yeah, stability assist system or something.
Yeah.
Yes, I think.
I might be getting that wrong. What was I going to say about the thrust vectoring? Oh yeah, the nice advantage of Kerbal Space Program is that you can just put a bunch of reaction wheels on there, and then it all works.
I mean, if you put too many, then it could be too heavy, and if you accidentally press D, your rocket will end up spinning away.
Yeah, that's true.
Yeah. But I'm always fascinated how the characters are still smiling when you're about to explode. Like, can you animate this to look a bit more scared? Because I was also positive it was going to work, but then I exploded. So why are you smiling? It feels like that.
The Kerbals have no fear of death. They only live for rocketry.
Maybe the Kerbals are not aware of death.
Yeah, they always respawn at the astronaut complex, right? So, so I started playing Kerbal Space Program in 2015, and you might ask, well, why did I do that? Well, in 2015, I was taking a course in orbital mechanics, and there was all these equations, and it's just like math and like variables and all this stuff that's like I don't even know how to conceptualize it. And I heard about, while I was taking this class, I heard about this game called Kerbal Space Program, and where you could like see all of the orbital things like physically. You could go and like make orbits and do stuff. I thought, oh, that's kind of interesting. Maybe I'll try it out. I started playing this game, and then everything that I was learning in the classroom all of a sudden made sense. So I don't know if in terms of orbital mechanics, I think it's a fantastic game at just really giving you a good sense of how things work when you're at least in interplanetary and these types of spaces.
Yeah, for sure. It was exactly the same with me. The biggest problem I had was picturing all the Keplerian elements properly. So I knew that, okay, there's a satellite transmitting this two-line element of its location, but it's a bunch of numbers. You don't exactly know what orientation of what it is. I don't even know if it's easy to show, but this was me practicing on my really bad glass board all the Keplerian elements that I needed to learn for a geodesy gravity exam that I had. And with Kerbal, it just became crystal clear. It's like, yeah, I know exactly what I'm talking about when I say this particular, and just figuring out all of these angles and Keplerian elements was really much better for me, just like for Josiah.
Yeah. And also the last thing I should say about this, because there was one other cool thing that happened in 2015, which is that in December of 2015, that's when the first SpaceX Falcon 9 booster came back and landed on the Earth, which was insane because before that, I had thought this thing that they were doing was impossible and they were all crazy. And why would you ever put landing legs onto a rocket? That's just dumb. And then I saw it happen. And I was like, oh my God, what? And then, of course, what's the first thing I did? And I tried to do it in Kerbal Space Program. Is it really possible?
The ultimate test.
Yeah. And I think that's the other cool thing about Kerbal Space Program is that although it's not like 100% to reality, of course, it's like still a game, but it highlights and at least exposes you a little bit to what could be possible. And there's all kinds of crazy things you can do in the game that we don't have in real life yet. So if it's a source of inspiration for people to try and make things in the real world, I think it's fantastic. And I hope they continue inspiring young people to get involved in space. What about your Kerbal Space Program history? Like, when did you start playing the game, and how does it impact you?
So I kind of don't remember when I started to play Kerbal. I know that I played from a while. I made the interesting stuff. I too tried to make to land a rocket with landing legs, and the first 9 tries I wasn't able to, meaning it exploded.
Yeah.
And about by the 10th try it worked.
All right. That's a slightly better than SpaceX because I think it took them like 15 tries.
But of course, that's real life, which is harder.
Yeah.
And also, their landing was smoother, let's say.
Okay.
My landing.
But on
Yes,
the
go on.
upside, you didn't lose as much money as them, so
Yeah.
you're definitely up there.
It because like the rocket would have just crashed into the ocean anyway. So
I love KSP. It's my favorite, and I could not recommend this more to people who like games, who like engineering, and of course who like space. It's uh, I think one of the most anticipated things right now for me is KSP2. I just can't wait for that game to come out. I think KSP is quite unique. It really helps you understand and see the concepts that you learn. It was one of the things that while I played before I started my masters really made sure like, okay, this is what I want to do for the rest of my life. So I think KSP 11 out of 10 would recommend.
What's the amateur rocketry in your country?
In India, I think there's quite some model rocketry going on, and there's still the private sectors are still kind of coming up where they have more experimenting. The regulatory aspects are relatively relaxed compared to here. But in general, about Germany, what we've been in contact with, KSAT from Stuttgart. We've been in contact with High End from Stuttgart. We've been in contact with Aris from Switzerland. And that's just a few teams. We've also been in touch with the Stern participants. The Stern event is from, again, DLR. It's a I think, annual or biannual participation opportunity for German students. Um, it's definitely really interesting, and the best part about creating the community, I think, is that we all share lessons with each other. We make sure that all of us don't have to repeat the same mistakes. How can we exchange some knowledge or lessons learned to make sure that the other person doesn't spend 2 months wasting time on a bad manufacturing technique, for example? Or if someone already had some regulatory issues, someone said, no, you cannot launch here, then we can make sure that we don't pursue the same launch site as them. So in general, I think the amateur rocket community in Germany is pretty helpful and exchanging well the knowledge based on all of the rocketry groups. Yeah.
Briefly talking about Canada, I think Canada has a pretty vibrant amateur rocketry community. It's kind of similar to America. This kind of, I think the main thing that allows or prevents amateur rocketry is just geography, right? So unfortunately in Europe, there's lots of people living in a very small space, so it's hard to do rockets that go much higher than a kilometer or two, because there's always the worry that you'll make a rocket that flies into someone's house or something, and that's no good. So in places like Canada or America, you have lots of open space, so that really helps on the regulatory side to allow people who don't have much experience to actually do really high power rockets. Despite that, though, I would say that in Germany, there's if you go down the right channels, which would be the academic channels, I would say, I think it's there are ways that you can get amateur rocketry and to do cool stuff in amateur rocketry with the structures that are in place here. So yeah, there's a couple of teams. I think that I would say there's teams that, I'm going to say this and I'm going to be wrong, but I would say there's teams at almost every university that is like a big, like the big universities at the big in the big cities. And you just have to kind of look for them. They're not always well publicized. The unfortunate thing about the amateur rocketry community is that most of us are engineers and we're terrible at marketing. So yeah. Finding us is the tricky part.
But that's no problem for you, Ettore, because you're starting pretty young, understanding the importance of social media. So we all have a lot to learn with respect to that. It's not just what you do, but it's when people know what you do that gets you ahead. So yeah.
I would say that when we started this project a year and a bit ago, I knew of maybe like 3 or 4 groups in Europe that did amateur rocketry. Now I know about like 50 or 100. So yeah. They're out there, and all of them are doing like pretty cool stuff. It's not, and lots of them have lots of experience too. So yeah, there's more than you expect. I think the Americans just do a better job of publicizing themselves. In the end, really the truth.
What are your favorite teams for the EuRoC 2022 or 2021?
If I pick my favorite, that's going to be bad, right? Someone might be offended. Well, I have a personal. I really like the Aerospace team. I think they have cool stuff that they do. I think they're in the S9 category this year, so they're building a solid rocket to 9 kilometers. Let's see who else is cool. High End is also sending one to EuRoC 2022. I think they just are sending a team of people who are like newer to the program, and that's how they like train their people before they start working on the big rocket, because they have like a big rocket that they're going to launch this year from Esrange, and it's going to go up. They're going to try and break the European record, so watch out for that. They might also be a good team to interview, so maybe check them out. High End, they're doing pretty cool stuff. They're building some pretty serious hybrid propulsion stuff. There, do you know the group Danstar?
Yes.
Yeah, they're also really cool. They have this crazy liquid engine that they've developed, the Gnome Child, and it's like intense. Yeah. I think they're doing another derivative of that at EuRoC 2022. They're in the L9 category, so I assume they're going to do that. they have been chasing the liquid rocket record, and if that could be one record they try to break at EuRoC 2022. If they make it to 9 kilometers, it'll be a record. Those are my favorites. What about you, Sahana? Do you have any favorites?
Since I'm in touch with most of them for knowledge exchange, I think I will keep my comments to myself.
See, I should have got my mouth shut.
I mean, they're all great in one way or the other, honestly, because I think sometimes it's really hard to compare, just like it's with any other challenge, it's a really geographical thing. Some people have more access to resources and facilities than the other. So I just think that it's really cool that everybody has something that we can kind of exchange and learn and be inspired from. So just the idea of EuRoC, I think the idea of the competition is great. That's it. Yeah.
Yeah. It's also a really cool competition because it's not just about going the highest. It's about like it's about being precise, right? So you want to get exactly 3 kilometers or exactly 9 kilometers. And like I think that's kind of the spirit of engineering, right? Which is to try to make something that works exactly how you intended it.
Yeah. I'm still till they always my jaws are always dropping when SpaceX just lands back exactly at the center of the circle that they promised they will. I just cannot imagine how mankind is doing something this precise. I mean, I'm so clumsy. I sometimes forget to put the cup correctly on the saucer, and it's like, how are they launching a rocket back to the center of this circle marked X? It's crazy. Yeah.
That's one thing to say about the Aerospace team because they're developing a parachute system that will actually, what they want to do is have it fly back to a precise spot somewhere.
Yeah, guided recovery is their quite a big strength.
Also, in the professional world, Rocket Lab is going to try to recover one of their boosters on Friday. So also check that out, maybe.
Will you do a live stream?
I'll do a live stream. Yeah, I'll live stream it. It's exciting. I got a live stream.
Do you plan to join rocket competitions?
We don't have any formal plans, but I think that maybe EuRoC 2023 is a possibility.
They would kind of be important because, as you can imagine, with regulatory aspects, it's really hard to kind of fly and see what you fly. So there would be like a good testing point or a milestone for us. So it would be great if we do get to go to a competition. And also it's sharing knowledge with other Rocketeers in person is just a whole other experience compared to what we're trying to do right now online. So would definitely be a useful thing for us to look forward to, maybe in 2023.
Also, one call out I would say for the European community is if we could have a competition where it was like open. So one thing that's crazy about launching in Europe is that it's really expensive. So if you want to go and get a launch site and you want to book a launch site for like 10 or 15 days, which is how long it takes to, put together and launch a rocket of our size, you're looking at like 100,000 to 200,000 euros. But if many groups in Europe could all come together and be like, well, we all want to build a rocket that's this big, and we all want to launch at a launch site that's like this, maybe we could have a competition under the guise of a competition, like 5 to 10 groups could all go to one launch site. And over the course of 10 or 15 days, we would all just chip in a piece to the launch cost that it costs to be there. And we all just try to go for space. I would love to see that.
So ride share, but different rides, yeah.
It's like launch share. You're sharing the launch site.
No.
Anyways, that's just Josiah dreaming.
That would be an economic cooperation.
Exactly.
Not much of a competition.
Well, we would be competing to see who gets there, of course.
Like who? Because if you all go to space, then that's not much a competition. So maybe who goes higher or who goes faster.
Well, we could have categories with like who goes highest, who goes fastest, who gets the most precise to what they said they were going to do.
Then everybody wins something because everybody wins in different categories, and then you have all winners.
Or you could just have it be a competition of who can get the closest, just like EuRoC, who gets the closest to 100 kilometers. Exactly. and then you just go for it.
Although if you get at precisely 100 kilometers, there would be a debate if you went to space or not.
Oh, come on.
Like maybe just go to 101 kilometers.
Yeah, we could make it like 105, and then it's like, okay. If you get it, you went to space. Officially, by the way, the Karman line, which was made by Karman, he's a scientist that was working on this stuff, and he defined the line as being about 83.4 kilometers. So, if you want to be officially to the book, as the past was, then you'd have to define it to be that. It's just the world community has decided, well, you know, give it a nice round number, 100 kilometers. And of course, in America, they say it's 80 kilometers, but they're just wrong. So don't listen to them.
They just had the miles conversion wrong.
Yeah, they're working in different units.
What do you plan to do in 2022?
Oh, well, we got so much stuff going on this year.
We're gonna clear our design reviews, starting with preliminary design review, critical design review. We're definitely hoping to pressure test. We're planning to do recovery tests. What are the milestones?
Well, did we say the propulsion test? Yes, you did, right?
Not yet, but you can.
Yeah, we will also do the small scale propulsion test with the small scale demonstrator. Will we announce something? That's part of the mystery. You don't know. We might. we have some crazy ideas for the future, and I think we have to make some decisions about where the group's going to go next after this milestone. We've kind of been really focused on getting to the Karman line so far, so we haven't really thought about it completely yet. But I think by the end of the year, we're definitely going to announce what the upcoming missions for ASTRA will be.
And let's hope that I don't have to find out about the announcements through Josiah's videos as well. And
No.
I don't get a review through the video.
You'll be. It'll be definitely an executive board decision.
Okay.
Do you sometimes have announcements that come through our videos?
Sometimes I see a notification and I'm like, oh, okay, and then yeah, okay. But really small ones, no big decisions. Yeah. But yeah, it's definitely an exciting year where I look forward to also more sponsorship, more fundraising that we're gonna look at, and a lot of testing. My favorite aspect.
What are your personal future plans?
I just want to participate in the aerospace industry and help to bring humanity closer to the stars. As silly as that sounds, I think that making space cheaper and making it more accessible to the common person is important. Part of that is launching, so making launch costs go down is really important. That's what a lot of companies are already doing, though. Companies like SpaceX, Rocket Lab, ASTRA. There's a company called ASTRA that works out of America. They're actually doing really cool stuff as well. They have the cheapest operational launch vehicle right now, so interesting to think about. But there's also other places where we need to try to make space more accessible and cheaper. So things like anything when you want to build that goes to orbit, right now is really expensive. If you want to build a satellite, if you want to build like a module to a space station, like, oof, man, hundreds of millions of dollars, right? So I think that there's some good opportunity there for trying to bring down the cost of in building these types of things. And that will be required if we want to have a growing industry that will expand exponentially into the future. Otherwise, it'll always just be a place where only rich people can play, which is not really cool.
Yeah, for me, immediate goals are definitely that I finish my master, see a good direction for ASTRA, and yeah, in the slightly longer run, I think I really like working as a bridge between science and engineering because because of my love for science, I understand the importance of the scientific objective, but with my experience with engineering, I know the technical difficulties that are there in implementing that kind of objective. So I kind of want to work as a bridge between the two. And it's definitely important for me that I work in a science exploration mission. Could be interplanetary, yeah. But this is something that I want for myself in the future.
There's also one thing that I think I'd probably be going to the commercial side, but there's one thing that would take me into the like mission, like private mission, like missions that are done by space agencies, and that is if someone is okay with getting me involved in doing a mission to Europa. It's a secret fantasy I have, which is I would love to design a probe that goes to Europa, lands on Europa, and starts drilling into the ice. That's what I want to see.
But these plans already exist, and it's actually just us space engineering, space science students that are so fascinated with Titan. But all the geomarine and the geology students are actually also eyeing Europa. So it's definitely a really exciting future to look forward to. Yeah.
I'm a secret geologist by night. Yeah. Well, what about your plans? Where do you see yourself in the future?
I would like to make my own companies, because I would say like one company that is cheap to make, which makes enough money to then so that I can then sell it and then use that money to make a company that does rockets. And I think it would be first it would have two things: delivering payloads to space. So like, I don't know, you pay $100 like per kilogram in orbit, probably more,
Wow,
or something
okay.
like that. And you can put whatever you want, except explosives, because rockets already have enough of that. And our second thing, which would be more towards science and, as you said, bringing humanity closer to the stars.
Okay, those are some big goals.
Yeah,
and many goals.
I hope I had that much figured out at 11. I mean, it's amazing.
I certainly wasn't thinking about making a company that I can sell so I can start a space company when I was 11.
I am planning to make the company that sells cooling with bricks.
Cooling with bricks.
Bricks have this thing that they absorb water, and when water evaporates, that takes energy. And so that means that if you soak a brick, it gets cold. And in some places, like where I live, which can get to like 40 degrees Celsius in summer, then it is useful to have some cooling in the house.
So the idea is that you would soak the bricks in the daytime and they would evaporate and that would cool the house?
The idea would be to have like a cooling with no electricity.
Ah, okay, I see what you're saying. Yeah, this is very useful, especially in India too.
Yeah, I was just gonna say that a lot of houses are built in such a way that they have rain trap systems in such a way that the rain gets trapped when needed and it flows into the bricks, and the bricks. All the brick houses keep it really cool. Most of us have brick houses. Yeah.
Yeah, not a problem I have in Canada. It's the opposite. We're trying to keep the heat in. Okay, so you want to start your own company and then use the capital gains to try to start a space company.
Yeah.
Yes.
One question I have is why not go straight to the space company?
Because like I want to start quickly, and I feel like you can't really just. So if you borrow money, there's the problem that if you don't earn that money, then how are you going to pay it back? So how do you build your first rocket?
Well, I would point you towards ASTRA Space then, because they started with no money and they collected a bunch of high-profile investors, and they have a war chest now of about like 500 million or so. So it is possible to start a company, a rocket company, with no money, as long as you continue to convince people to give you money. I think Rocket Lab also is like this. Peter Beck was not a rich man. He was just a crazy kid that liked building rocket stuff. And he has this one thing where he had like a rocket bike or something.
I think it's going to be easier with more money.
You think so? Okay. So you're going
whatever it is, we're excited to watch the journey. Yeah.
Yeah, the Elon Musk approach.
Yeah, he did PayPal.
Yeah. Yeah, he did.
Sounds like a good time to let you know that you can also use PayPal to donate to ASTRA.
Indeed.
Okay, so what advice do you give to young Rocketeers?
Be bold. Try new things. And make sure you're standing far enough away that if it explodes, you don't get hurt.
Yeah, keep your curiosity alive. Try to keep at it if things feel difficult. Yeah, it's okay. It gets better. Then maybe not right away, but things do get better. And knowledge is definitely irreplaceable. So just try to make sure, like just like Neil deGrasse Tyson says, make sure that you know more today than you did yesterday. And exchange knowledge, share knowledge, because this goes a long way. Yeah.
And also one thing that when I was younger, I was not thinking about this. I always was thinking like, oh, I need to join something. I need to find a place where I can join something so that I can do cool things. But you don't need to join anything. You can just do cool things and start it on your own. And people will come. People will be attracted to it. So if you're young, maybe you have a high school that doesn't have a rocket team, make a rocket team. Right? There'll be students that are in your school that'll be excited about that, I'm sure. So yeah. Don't wait. If you want to do it, just go out and do it.
Yes, I have tried. And I've got one person that is not me. But I did try to make a lot of advertising, but it didn't seem to work.
No?
But unfortunately, there are not enough people to make a PR department.
Well, one person is a start, right? I think that's a start. I think when you get a bit older, it'll be like once you get into high school age, I think there'll be more people. And in a high school, you have more people in your environment that you can kind of start to talk to. Yeah.
Okay. What are your favorite space movies?
I think can suggest a documentary I really like, The Farthest, I think it's called. It's about the Voyager mission. I really like this because of the aspect that it shows the human side to it. They show you how they were having tiny pillows and blankets on the floor and just sleeping in the control room. And yeah, I really like this documentary with the idea of how you get to see the whole picture and not just a fancy simulation or just the launch, but the entirety of what they faced during the whole time. Maybe not a movie, but I really like the book called Starship Citizens, where it kind of compares all the teachings from the elderly group from the indigenous groups and how you can use this in case we decided to all move to a starship. So yeah, these might be my favorite.
Yeah. For me, I obviously I'm kind of an old timey person. I like 2001: A Space Odyssey. Maybe that's a bit slow for today's generation, but I'm okay with the slow pace. I think it's a very beautiful movie for the time that it was filmed in. Obviously, it doesn't have like super high quality graphics and everything, but it's a journey into the unknown, which is cool. More modern, I like The Martian as well, the book and the movie. I read the book and watched the movie. I think the way he problem solves is really like that's the epitome of what being an engineer is. So I think that's great. In terms of rocketry YouTubers, I think that Tim Dodd, the Everyday Astronaut, he's a really cool guy to follow and stuff, because he gets into like the technical details of like all kinds of rockets, and he really goes into depth and tries to really figure it out. And tries to figure out in a way that just somebody who's just like, I'm interested in rockets kind of, but I didn't go to aerospace engineering in university, but I still want to understand what's going on. I think he's a good source for that. Yeah. And of course we all love Scott Manley.
Yeah.
He doesn't need more promotion.
Yeah. He taught me more orbital mechanics than a lot of books I was reading. So yes.
Yeah, he's definitely been quite useful. He also kind of taught me how to play Kerbal Space Program, so that's good too.
And he's a very calming resource just before the exams. Also.
Yeah, surprisingly.
Yeah. You think you're just having entertainment on YouTube, but you're actually learning, and then it fits. Yeah.
He also knows a bunch about like nuclear stuff too, which is interesting.
Do you have any questions for me?
Oh, I have a ton. We might be here all night. One question I have that comes out is, why did you choose to start doing this? Like, was this just all your idea and you just started interviewing these rocket groups, or was this because of a project or something that you were starting? Is it because of something you're doing in school?
So I make rockets, and I have noticed that my liquid fueled rocket engines that I'm making from like a year, I haven't made much progress. Not even another thing. So I decided I could interview some teams to learn some stuff from them.
Okay, so you just wanted to kind of, it was more of an information sharing campaign that you were kind of on.
Yes.
Okay. I noticed that you have very good English skills for an Italian at 11 years of age. So I'm curious, do you have an English parent?
So for some reason, everyone in my school says this. The reason is it's kind of weird, but when I was smaller, I liked playing Minecraft. And there was this thing that there were no good Italian tutorials for Minecraft. So I ended up watching the English tutorials, and after a while, that's how I ended up learning English.
Oh, okay.
That's amazing.
Just from Minecraft?
Yes, and
Okay.
they like commands, which are kind of like code, and it's all in English. So, again, English.
That's
Huh.
awesome. Yeah,
Okay.
it's like Japanese from the anime, and I learned a bit of French just to read the Asterix and Obelix comics. And I didn't like how it was translated, and of course a lot of German from the metal songs. Just it's crazy how these sources just push you to learn different languages.
Well, you guys are both putting me to shame because I only speak English and I've been trying. I speak a little bit of German now, but man, languages aren't my thing. And you just pick it up like, boom, oh, I watched some tutorials in Minecraft and now I'm an expert.
Yeah, at 11, I think I barely spoke one language. It's amazing. Yeah. Yeah, maybe I have another question for you. What did you do exactly with planetary defense?
Like on the NASA website, there was this little test on some things, and because I knew kind of a lot of stuff on asteroids, this is what I got, and this just fills up this blank space here on the side.
It's a bit more than just a blank space. It's pretty cool that you did something with citizen science, I guess, at such a young age. Yeah, you should feel like an Avenger or something. This is pretty cool.
So bye and thank you.
Yeah, thanks for having us.
Thank you.
Yes, thanks for coming.
Yeah, it was a pleasure.